Hello, in this module we will see how to work with R to analyze data obtained from cohort study. As we have seen in earlier module how to work with relative breaks and attributable breaks, and these tools are useful to handle with cohort study. Here we will see something different kind of statistical tool to handling cohort study data. Cohort study, it's a prospective study where a group of individuals followed for long time and presence of some exposure been observed, and those exposure having any contributions on their disease or not, that we study through cohort study. Since it is a observation of group of individuals through follow-up study, the same study design can also be taken in clinical setup where all individuals having disease presence and those individuals being observed through follow-up periods, and to those individuals 2 or 3 different type of treatment being given and effectiveness of treatments being observed through follow-up durations. So, in clinical setup, the group of individuals with presence of disease can be followed by different visits, and the data is analysis is important to be analyzed through cohort study setup also. In this module, we will see how to handle a group of individuals who have disease, and as a cohort how they have been followed, and once they had followed, how to analyze data on those individuals. Here especially we will see how to prepare data for suitable for cohort study data analysis, how to visualize data with one example data. We will say something about the mixed effect and as well as the random effect part in the data, and after that we will handle the mixed effect and random effect part in this data set. In this module we will see how to prepare data for cohort study, how to visualize data for cohort studies, and applications for fixed effect modeling and as well as random effect modeling. Here this is data for preparations. In cohort study we generally follow some individuals for long time. Broadly, the cohort is basically to see a group of individuals for long time, and based on that their disease progressed or not, any kind of exposure is there or not, and as well as any behavior we do see, and after based on this exposure and behavior we try to find out that disease occurrence or not. That is a typical cohort study, but in addition to that there is another cohort study where a group of patients followed for long time through follow-up visits, and we do check their treatment effect and other behavioral changes and these factor changes. As far as statistical tool are concerned, for first type of cohort study where we started for individual group and those are not having disease and followed for long time, for that statistical tool like relative breaks, attributable breaks, are important, and in earlier modules we have seen how to prepare table and how to analyze data for that. But here we are going for another type of cohort study, where we start with group of individuals, those are having disease or under some kind of trial, and we do follow them for long times with treatment effect, where the main concern is that how effective treatment is there, how their parameters, primary parameters linked with their disease is increasing or decreasing through the treatment. That is the main intention to any cohort study. And here we will also consider here a data set on systolic blood pressures, that is on parameters to check the blood pressures of those patients having the coronary heart disease. And the intention of any coronary heart disease trial or study is to provide some kind of treatment or therapy to the patients, and after follow-up tries reduce these parameters of interest, that is systolic blood pressures or diastolic blood pressure. So here we are considering systolic blood pressures, and the whole functions we will run with the help of library called NLME, that is stand for non-linear mixed effect modeling. And before that we will see how to prepare the data set, suitable data set for analyzing and visualizing the data, because one of the important area in cohort study is to visualization of the data, because here we do consider the same individuals observations repeatedly over time, and during repeated observations each individual's measurement keep on changing, increasing or decreasing. So making the pattern of these covariate changes is very important. So here is the data set, where the first variable is the systolic blood pressures measurement taken, and here we are not considering repeated measurement of SBP, we are trying to prepare some kind of systolic blood pressure repeatedly measured. So now since we are provide the systolic blood pressures in R, and thereafter we are going for to prepare a matrix of these SBP, and we are in second line we are putting SBP as matrix of SBP of n columns. So SBP, the same SBP will be repeated for 5 times, 5 columns, and after that we are putting this another variable named with Tx, that is treatment, and assigning as 1 and 2. So 1 may be considered as the placebo and 2 can be considered as any effective treatment that is useful to reduce the systolic blood pressure to the patients. Now we are using the function data frame, and data frame within parentheses we are putting subject equals to paste of S for 1 to 16. So 1 to 16th time the S will be repeated, and SBP and Tx will be repeated same way. So let's see how these functions giving us the data. This is the SBP.df that we are calling, and getting the first column as a subject, and subject is assigned as S1, S2, S3 up to S16. Second column giving as a X1, that showing the 126, 134, 141 like systolic blood pressure measurement for subject 1 to subject 16. Second column, third column X2 is showing these the same individuals repeatedly measures systolic blood pressures. X3 the third visit systolic blood pressure showing, X4 showing these fourth visit SBP measurement, and like X5 giving the fifth visit SBP blood pressure measurement. And seeing these patients were treated initially from treatment 1 and they followed from till treatment end, so they were not shifted or changed into another treatment. So corresponding patients, corresponding subjects treatment are given as a Tx either as 1 or 2. So it can be stated that from subject 1 to subject 8 were treated with Tx1, and subject that is SN9 to SN16 were treated with treatment 2. Now some others work also. Now the names of SBP-DF, that is assigned as that X1, X2, X5, X3 as assigned as subject and y1, y2 up to y5, and sbp.bf again assigned as a reshape of this variable as y of 1 to 5 and 6, and time variable is assigned as a days, unit in days, and these are separated with a comma, and after the direction is a long format is used to put the variable. So that is important to be used to prepare your data when you are going for follow-up studies through cohort studies, and that is suitable to applicable for the data. Now again we are groupifying the data as sbp.df as group data where y follows to days given subject is concerned, and after that data is equal to sbp.df com. Now we are calling this sbp.df. Now it's giving us as a group data where y follows days given subject, where subject 1, 2, 3, 4, 5, 6, 7, 8, 9, where with treatment 1 up to subject 8 were in treatment 1 and 9 was given treatment 2, and their corresponding days measurement of SBP is given as days and y. Now we are going for data visualization, and that also comes as a called as a exploratory data analysis, where we take the graphical exposition of the data. That is very important step to be considered before applying any data analysis. Here this library called Lattice is very useful with data explorations or data visualizations. Here we are using xy plot functions to visualize the data, whereas y axis we are putting these y individuals, that is systolic blood pressure measurement of those individuals, and as a x axis we are assigning the days of those individuals, and here we are having 5 repeated measurement of each individual. So days are assigned as 1, 2, 3, 4, 5, and here it is that see that xy plot within parenthesis y follows to days given tx is considered, where groups is equals to subject is has been assigned, and type is equal to o is considered to preparing the plot, and strip plot is used here, and the panel dot superpose is used to preparation the visualization graph. Now we will see the graph. This is the graph separated for treatment 1 and treatment 2, and for treatment 1 those individuals were having high systolic blood pressures, they all reduced, and individuals level, that is 8, since treatment 1 were having total 8 patients were treated in treatment 1, so 8 individuals separated plots are there with different colors, and the same in treatment 2 again 8 individuals were treated, so again 8 different colors were given. So it is to be noted that pattern of those individuals in treatment 1 was having lower systolic blood pressures in comparison to treatment 2. However, in both cases systolic blood pressure has been shown to be reduced dramatically, and all individuals having reduced systolic blood pressures at the end of 5th visit, and the visits are given as days through the x-axis as given as 1, 2, 3, 4, 5. So 5 points observations were there, and 5 plotted data is here for data visualizations. Now we will go for further analysis for this data set. This is the initial model. We are going for LME model, that is linear mixed effect model, and I will come to why we are going for this mixed effect model. It is to be noted that in the graph we have found that some individuals having reduction more of systolic blood pressure in comparison to other, whereas both of them were treated in the same treatment. So it's called individual variation. So how patients or subject is behaving on specific drug is depend on his individual's level of variation. So that variations or subjective variations or individual level variations can be solved or captured through random effect modeling, and when some factor like days and treatment that is not going to change, that is fixed over the all patients or over the treatment period, this factor can be considered as a fixed effect factor, and the combination of this kind of two factors, that is random effect and fixed effect, can be classified as a mixed effect. And to run with the mixed effect, the function LME is useful. So we are having intention to run with the linear mixed effect modeling here, and for that the library LNME useful. Now since we had assigned the y as a SBP follows by factor of Tx, and the Tx is considered one of the fixed effect factors with multiplied with the factor d days. So days also considered here as a fixed effect factor, because days wise and the treatment wise there was not any changes towards the subject, so these were fixed for all individuals. So these two factors have been considered as fixed effect, whereas random effect is considered as a subjective variation. So individuals were having different variations, treatment variation on their own, so subjects are considered as a random effect. And so that is the meaning of these functions, and after that data is equal to SBP.df is considered to assigning the data set. Now when we are calling the ANOVA of LME1, then we will get the results as intercept, factor for Tx, factor for Ds, and the multiplied or interactions factor between Tx and Ds. So as a factors we are getting that intercept value, regression coefficients of intercept value is coming as our estimate of intercept is coming as 11303.237, having obviously significant level. And for factor Tx, that is considered as a fixed effect, that is not changed to any individuals from start day to end follow up last visit, they are giving the same treatment. That regression coefficients obtained with 0.290, having p value 0.5984, and for the factor days it came the regression coefficient value as 109.537. Again it is having significance p value like 0.0001, and now the intercept between Tx and days it's coming as a 0.294 with significance level with p value as a 0.8806. So there is not any interaction effect between treatment and days that can be noticed here, but obviously days were having significant role to reducing the systolic blood pressures. That's why p value for days is coming less than 0.05, and whereas treatment was not having any significant role to reducing the systolic blood pressure. That's why treatments Tx corresponding p value is coming 0.5984. Now we are going for to getting the estimates about the fixed effect model that we have considered here as a treatment and days, and as we have noticed that AIC stand for Akai information criteria and BIC here stand for Bayesian information criteria, and log like is given as the log likelihood of these estimates of the value. So as a result we can see that AIC value is coming 426.03, BIC 453.01, and log likelihood coming 201.01. So now based on these AIC value and BIC value we can compare several models and we can find out which model is best fitted. Since here in this condition we are considering only one model that is having fixed effect as a Tx and random and fixed effect as a days, and subject is considered as a random effect, so there no choice to AIC comparison. But when we will go for more factors consideration, then the AIC can be compared, and thereafter the best fitted model can be find out. Now we are coming to the estimates value that we are getting by fixed LME1. As a fixed LME1 for treatment we are getting the value is corresponding standard error value, and as a t value and as a p value, and factor for d. Now one thing to be noted that since we are having treatment 2 and days 5, so whatever estimates we are getting here is basically for treatment 2 with respect to treatment 1, and again treatment days 2, 3, 4, 5 with respect to days 1. So it is to be noted that in this result part, the intercept is coming as 134.250, standard error 1.89, with degree of freedom 56 and t-value 70.75, and you are not going to consider as a statistical inference about the intercept, but second row if you consider in the table that factor of tx2. So treatment 2 is coming with respect to treatment 1, that's standard regression coefficient value obtained as 2, standard error is 2.68, degree of freedom 14, t value 0.74, and again p value 0.46. So it shows that treatment 2 were not having significant role to reducing the systolic blood pressures in comparison to treatment 1. Now coming to days 2, that is again coming t value minus 3.37, standard error 1.41, degree of freedom 56, t value minus 2.38 with p value 0.0205. So it shows that days 2 is having significant reduction on systolic blood pressure in comparison to days 1. Again, like days 3 again shows that it is having highly significance in comparison to day 1. Day 4 again shows that it is having highly significant reduction of systolic blood pressures in comparison to day 1, and the corresponding regression coefficient for day 4 is coming minus 15.125, standard error 1.41, t value minus 10.68, and p value 0.00. And for days 5 it's coming again minus 17.37, and again it also highly significant reduction of SBB value. Now next row is interaction effect of treatment 2 with days 2. After that, interaction effect with treatment 2 with days 3, interaction effect with treatment 2 with days 4, and corresponding treatment 2 with days 5 is given here. In case we can say that none of the interaction effect having significant role reductions on the systolic blood pressure. So this is a way to interpret the fixed effect modeling when you are going for cohort study, when you are going to follow some individuals for follow-up time. And now we will go for random effect model. Now we will go for covariance structures between model. So days 1 with treatment factor 2 and days with treatment factor days factor 2 is corresponding correlation coefficients or covariance structures can be find out here. Now we will go to next slide to get the interval estimates of these fixed effect parameters. So corresponding to the estimates we got as a treatment and days, here we are getting the corresponding lower confidence interval value and upper confidence interval value, and for treatment 2 we are getting lower confidence minus 3.75 to 7.75 for treatment 2, again corresponding for days 2, days 3, days 4, days 5, and having corresponding lower and upper confidence interval of the estimates. Now we will go for random effect. The slide should be on random effect modeling. So here as a when we are calling the random effect, we are getting this random effect, that is subjects with lower and upper interval as a 3.05 to 6.79, and within group standard error is coming 2.35 to see. Now these variance covariance matrix can be obtained for this random effect as var-core matrix. Here for intercept values obtained, and after that the random effect for first 11 individuals is given, and somehow see the for S1, S6, S12, S4, S10, S14, S is having negative regression estimates value coming minus 7.54, minus 6.42, minus 5.57, minus 3.45, minus 4.08, and minus 8.00, whereas for individuals S15, S2, S5, S16, S7, S13, S3, S9, S8 and S11 having positive impact on the systolic blood pressures. So that is the estimates about the random effect, whereas we have considered the subject is having random effect, and this var-core for LME1 is given with their estimates value and standard error value, and that is very important to be considered, that what is the variance among these subjects that need to be considered with this corresponding standard error. So when we are having this kind of data set where we are having more than one follow-up visits, and we trying to find out these how these follow-up wise this primary endpoint has been changed, then the factor like fixed and other factor like random effect need to be considered separately for model building, and those things can be done with mixed effect modeling. And I hope this kind of data set or illustration will help you to do other study where you are having cohort or group of individuals and follow for longer time and find out the treatment effect on them. Here in this module we have seen how to prepare data for cohort study, how to visualize data for cohort study, as well as how to handle mixed effect and random effect in the cohort study data. So this kind of work can also be carried in R, and here we have present one suitable example from cohort study.